for 16.7 tangent planes and normal lines. So say we have some x, y, z with a parallel vector. Okay, so a parallel vector, and we'll say that that parallel vector is a sub 1, a sub 2, and a sub 3, whatever those values are, okay? X is going to equal x sub 1 plus a sub 1 t, and again, this is a vector. Y is going to equal y sub 1 plus a sub 2 t, again, that's a vector. And then z is going to be z sub 1 plus a sub 3 t. Or again, your a sub 3 is your vector, okay? Here, our a sub 1, a sub 2, a sub 3 is normal to the plane. Is normal to the plane. Okay? So here's what an equation would look like. It would be a sub 1 x minus x sub 1. Oops, I started to write that as a vector, sorry. That should be a parenthesis. So parenthesis plus our a sub 2, y minus y sub 1, plus a sub 3, z minus z sub 1, and that's going to be equal to 0, okay? Where our f of our x, y, z is equal to 0, if some p naught is a point on the graph S, our vector is going to be our f evaluated over that p naught, okay? And remember that the little upside down triangle is your directional derivative in gradient form, okay? So, and this is normal to the tangent. Okay. All right, so let's look at how we would do one of these. Let's look at an example, okay? So say we have this 3x cubed minus 4y squared plus z squared plus 7 equals 0 at the point, we'll just say 1, 2, 3, okay? At the point 1, 2, 3. All right. So here we have our f of x, y, z equal to, well, let's do the derivative. So this is going to give me 9x squared, and that's my I hat because that's my x term. And then minus, well, doing the derivative here, that's going to give me 8y j hat plus the derivative of that is 2z k hat. All right. And then let's go ahead and plug in our 0.123, okay? So that's going to give me my 9 I hat, because 1 squared is 1, 1 times 9 is 9, and then minus 8 times whatever my y is, which is 2, so that's 16 j hat plus 2 times z, which is 3, so that's 6 k hat. All right, so let's look at the tangent plane. Okay, very similar to tangent lines, except now it's three-dimensional, so we have a tangent plane. So we have 9 times our x minus 1. Again, the x minus 1 is with my 0.1, so that's where that comes from. So 9 times my x minus 1, and then minus my 16 y minus 2, and then plus 6 times my z minus 3, and then that's equal to 0. Okay, so let's go ahead and do the math on this. This gives me 9x minus 9 minus 16y plus negative 16. Negative 2 is positive 32. 6 times z is 6z. 6 times negative 3 is negative 18, equal to 0. Let's move all my constants over. So I have 9x minus 16y plus 6z equals 9 minus 32 plus 18 when I move over my constants. So that's 9x minus 16y plus 6z is equal to, and that gives me negative 5. Okay, so now my normal line is given by x equals 1 plus 9t. My y is equal to 2 minus 16t, and my z is equal to 3 plus 6t. Okay, now here's the way to think about this. Your x is 1, your y is 2, your z is 3, so 1, 2, 3. And then we have a positive 9, a negative 16, and a positive 6. So positive 9, negative 16, positive 6 for my z, my y, and my x. Okay? Page 860, problems 1 through 6, 11 through 14. And again, if any of this was confusing, make sure that you have watched the directional derivatives at 16.6 so you understand these directional derivatives, okay? And remember that this signifies the gradient, okay? And that's your directional derivative in what we call gradient form, okay? I hope that helps.